There's a couple of different ways of doing this. You could use the formula for arc length, S equals R times theta, where theta is in radians. I guess I'm doing it this way no matter what. Because when I looked at this problem, I thought of, well, I mean, think about what radian measurement means for an angle. Okay, the radians is measuring how far along the unit circle. So how far along the circumference of the unit circle are we going? So unit circle has a radius of 1. So 3 pi over 5 means you haven't made it around the full circle. You've made it pi over 2, so that's bigger than pi over 2. You've made it just about here, right? Because if the unit circle is a radius of 1, then 2 pi is all the way around. So that means 1 pi would be a semicircle, and that means half a pi would be here. So 3 pi over 5 is somewhere over here. That's the arc length. And so to calculate that arc length, this is the arc length when the radius is 1. If the radius is 3, we just need to multiply it by 3. So it's 9 pi over 5. But you get the same thing if you plug that into the formula here. Okay, so the next part, that's a poorly drawn question mark, but it's supposed to be a question mark. We're supposed to find out the radius. So same thing, we can convert this to radians, and then we can just use this formula for arc length, okay, because that's all going back. Radians and arc length formula are always going back to that unit circle idea. So 195 degrees, if we need to convert something to radians, convert degrees to radians, so we take the degrees, we divide it by 180 and stick a pi on there. And if you're wondering where that comes from, it's because 195 degrees out of a whole circle, there's 360 degrees in a whole circle. This is the fraction of the circle that you're talking about with this angle, right? And so you multiply the fraction of the circle that's cut out by your angle, you multiply that by the circumference of the whole circle, because radians is the distance along the circumference, right? But 360 and 2, they simplify, they can cross simplify, and so that's where we get the 180 over pi thing. So the short of it is, to convert from degrees to radians, divide by 180, multiply by pi. So now we have a radian measurement, it's just not simplified. But we can plug that in the formula along with 7 for an arc length, and that will be the radius. Oh wait, sorry, it goes over here. The arc length is 7, so that goes over for S in the formula. The radians, 195 over 180, I don't know how that simplifies. 195 divided by 5 is 39. 39 over 36. So 39, I also can simplify 39 divided by 3. So that's 13, and then 13 over 12, 13 pi over 12. So that's our radians, and then we don't know R. So I plugged this in for the radians. I think I might have underlined R on accident, but I plugged in our angle measurement in radians, and now we just need to solve for R here. So you'd multiply 12 over 13 pi to both sides, multiply by the reciprocal. 12 over 13 pi times 7. Okay, and then once we simplify that, that's 40, wait, that's 84 over 13 pi is the radius. So we're just really plugging stuff into this formula. The last one, we need to solve for the angle. They give us a radius of 6, and they give us an arc length of 5 pi over 3. So to solve for theta, I'm going to multiply 1/6 to both sides. So I get 5 pi over 18, and it's already in terms of pi, so that's a nice radian measurement. Okay, so that's the angle that needs to go for this one.